In this lesson, we'll show how to find the angle between two vectors using the dot product. Remember the basic formulation for the dot product. A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle theta between the two vectors. If you have each of these vectors in Cartesian vector form, you simply multiply the x components together, add them to the y components when multiplied together, and add that to the z components multiplied together. So let's begin with our first problem. Here we want to determine this angle theta between the position vector r1 and r2. Well, to solve the problem, the first thing we'll do is express each of these vectors in Cartesian form. We'll begin with r1. That's pretty straightforward. r1 is equal to minus 2 times k. Now let's look at r2. It has components along the x-axis, the y-axis, and the z-axis. If I write it out, it'll equal minus 1i. We have plus 2j. And finally, minus 2k. We also need the magnitude of each of these vectors. And in the case of r1, that's pretty easy. It's equal to 2, isn't it? Now the magnitude of r2. What do you think that would be? Well, it's simply the square root of minus 1 squared plus 2 squared plus minus 2 squared. And that's the square root of 9, or the answer is 3. Now that we have this set up, we can apply the dot product. And when we do it, we have the following. r1 dot r2. Well, there's no I component up here, and there's only one down here. And so minus 1 times 0 is our first term. And then, of course, it's 0. Now the j terms. Well, there's a 2 here, but there's nothing up in here. So again, we have 2 times 0, or we get a 0. And one more to go. Minus 2 here times minus 2 here. So let me put that in here. And then, of course, we set all of this equal to magnitude of r1, which is 2, magnitude of r2, which is 3, and then we have our cosine of theta. All we need to do is solve for theta here. And doing that, theta is equal to the arc cosine of 4 divided by 6. We get the result of 48.2 degrees. Looking at the drawing, that seems about right. Now we'll do a second problem, which is very similar to the first one. We want to find the angle theta here between r1 and r2. Well, to do it, of course, we have to express each of these vectors in Cartesian form. We'll begin with r1. It has components along the x-axis, the y-axis, and of course the z-axis. So r1 is a Cartesian vector is equal to minus 6 I. We also have plus 3j. And finally, minus 2k. And now we'll do r2. It has components along the z-axis, the y-axis, and of course the x-axis. So writing it out, I have r2 equaling minus 2i plus 4j, and finally minus 4k. Next, we have to find the magnitude of each of these vectors. Well, to do that, we simply take the square root sum of the squares of the components. In other words, the square root of 36 plus 9 plus 4. That's the square root of 49. Turns out to be 7, doesn't it? Now let's get r2. That's the square root of 4 plus 16 plus 16, or the square root of 36. And so we get 6. Having all this now, we can apply the dot product and find our result. First, r1 dot r2. So we take our minus 6 and multiply it by minus 2. And then we add to this 3 times 4. And finally, we have our last terms, which is minus 2 times minus 4. We set all this equal to r1, which of course is 7, and we have our 6. We also multiply this by the cosine of theta. Now that this is all set up, we simply figure out the result over here and divide by this number, which is 42, and look up the arc cosine of the ratio, and you'll get the answer for theta, which turns out to be 40.4 degrees. All right, and now we come to our last problem. We want to determine the angle between this force and the OA axis. Well, to do that, we need to set up a position vector going from A to O. And the angle we're looking for is really defined right in here, our angle theta. So now we need to look at each of these as Cartesian vectors. Well, F is already given, but we do need its magnitude. So let me take a moment and we'll calculate it first. As you know, it's equal to the square root of minus 6 squared plus 9 squared. And finally, we have plus 3 squared. And if you work this through, you'll get an answer of 11.22. And it's in kilonewtons. Next, we have to formulate R as a Cartesian vector, and of course it has components along the z-axis, the y-axis, and the x-axis. So writing it in Cartesian vector form, R of AO is equal to minus 1i. We have plus 2j. And finally, we have minus 2k. We need the magnitude of this vector. That's pretty straightforward. R of AO is equal to the square root, sum of the squares of the components, or the square root of 9, turns out to be 3. And this, of course, is in meters. Now we can apply the dot product and find our answer. First, we need to determine the dot product. So taking the terms, minus 6 times minus 1. Then we have 9 times 2. And finally, we have the product of 3 times minus 2. There we go. And we set that equal to the magnitude of f, which was equal to 11.22. Finally, we have the magnitude of R of AO, which is equal to 3. Multiply this by the cosine of our unknown angle, theta. Now, in order to get the result, we simply calculate this number, and then we divide by this one, and look up the R cosine. Realize that the units will cancel out, of course, because each term is in kilonewton meters. And so having completed the problem, we'll end our lesson.